Look at any crowd on Earth, and you will observe something remarkable. A single species, sharing the same bones, blood, basic brain, and an ancient family tree, yet displaying skin tones ranging from very dark brown to very pale pink. For thousands of years, humans struggled to explain this difference, often in the worst possible ways. They wove it into myths, then into the fabric of tribes, empires, and eventually, the concept of race. People began to act as if skin color definitively separated humanity into distinct kinds of people. However, biology tells a profoundly different story. Skin color was never proof of human separation. It was never truly about the labels we use today. Instead, it was about a universal problem every human body had to solve, a challenge that literally fell from the sky. The strange paradox is that the very thing essential for human life was also capable of causing damage. Over thousands of generations, our ancestors' bodies had to find a delicate balance. Block too much of it, and you face one kind of demise. Let too much in, and you succumb in another way. So, why did humans develop different colors? The answer predates nations, borders, or races. It begins in Africa, with a small, exposed, sweating ape standing beneath a relentless sun. For most mammals, fur serves as the primary defense for skin. It provides shade, acts as armor, and blocks sunlight before it ever reaches the skin. But our ancestors made a dangerous trade. They lost most of their fur. While the exact timing remains debated, the leading explanation points to heat. A fur-covered animal quickly overheats when running in open sunlight. In contrast, a mostly hairless animal capable of sweating possesses a unique advantage. It can maintain continuous movement. It can walk for hours, run for hours, tracking animals across hot, open terrain while other predators are forced to stop and cool down. Sweat functions most effectively on bare skin. Thus, early humans exchanged fur for a more efficient cooling system. However, this exchange created a new problem. With the fur gone, the sky's elements could directly impact the body. And near the equator, sunlight is far from gentle. It carries powerful ultraviolet UV radiation. UV light is strong enough to burn skin, damage DNA, and break down crucial molecules within the body. One such molecule is folate, a B vitamin essential for cell production, DNA repair, healthy sperm, and supporting early pregnancy. If excessive UV radiation breaks down folate, reproduction becomes significantly more challenging. In the grand scheme of evolution, reproduction is not a minor detail. It is the ultimate test everything must pass. A body can be strong, fast, intelligent, and perfectly adapted in every other respect, but if it cannot successfully leave descendants, evolution quickly discards that design. Therefore, as early humans lived under intense tropical sunlight, natural selection favored bodies capable of protecting folate. This protection came from melanin, the pigment that gives skin its color. Melanin is more than just a color. It is a biological shield. It absorbs and scatters ultraviolet radiation before that radiation can inflict significant damage. The more dark, protective melanin your skin produces, the better protected you are under strong sunlight. This explains why populations whose ancestors lived for extended periods near the equator tend to have darker skin. Not because they represent a different kind of human, but because their ancestors lived under more intense UV radiation. Dark skin was not a cosmetic feature. It was survival technology, the original sunscreen. But then, humans began to migrate. Slowly, over tens of thousands of years, groups of Homo sapiens spread out of Africa. They traversed deserts, followed coastlines, moved through forests, and eventually reached cold plains, cloudy islands, mountains, and northern skies. As some groups ventured farther from the equator, the problem shifted. The danger was no longer solely too much sunlight, but too little, specifically, too little UVB. UVB is the part of sunlight your body uses to produce vitamin D, an essential nutrient. Your body uses vitamin D to absorb calcium, build strong bones, support immunity, and maintain normal biological function. Without sufficient vitamin D, children can develop rickets, a disease where bones become soft and deformed. Pregnancy becomes riskier, bones weaken, and overall survival becomes harder. So now, human skin faced the opposite challenge. Dark skin, while excellent under powerful tropical sunlight, could block the limited UVB the body needed in regions where the sun was weak for much of the year. Consequently, in many low UV environments, natural selection favored lighter skin. Less melanin meant more UVB could penetrate the skin, leading to more vitamin D, stronger bones, and improved chances of survival. This is the aspect most people misunderstand. Light skin did not evolve because cold places are cold. Cold does not bleach skin. Sunlight does. The true map is not temperature, but ultraviolet radiation. That is why human skin color correlates more closely with sunlight intensity than with heat. However, the story is still not as simple as dark skin near the equator and light skin in the north. Humans are complex, and so are migration, diet, and history. Some Arctic populations, for instance, did not become extremely pale despite living far north. Why? Because many of them traditionally consumed diets rich in fish and marine mammals. These foods provide vitamin D. If your diet supplies vitamin D, your skin does not need to allow as much weak northern sunlight to penetrate. Thus, diet can significantly alter the evolutionary pressure on skin color. This is why no perfect, universal skin color chart exists. There are patterns, but not neat, distinct categories. This is precisely where the concept of race begins to unravel, because skin color changes gradually across geography. It does not divide humans into tidy biological classifications. There is no sharp line where one type of human ends and another begins. Instead, there are populations whose ancestors adapted to varying amounts of sunlight, who then mixed with other populations, moved again, and adapted anew. If you had walked from Central Africa northward thousands of years ago, you would not have crossed a magical border where humans suddenly changed. You would have witnessed gradual shifts, different bodies shaped by sunlight, diet, migration, and chance. Human variation is undeniably real, but the rigid boxes people constructed around it are primarily cultural. Skin color became one of the most visible human differences, so societies imbued it with meaning. Then they assigned it a hierarchy, which often led to violence. But evolution never dictated any of that. Evolution was merely solving a chemistry problem. How do you block enough sunlight to protect folate, yet allow enough sunlight to produce vitamin D? That is the entire puzzle. Too much UV, and you need more melanin. Too little UV, and too much melanin can become a disadvantage. Human skin color is the compromise, a dynamic balance between protection and production, between blocking the sun and utilizing it. The most fascinating part is that this balance evolved more than once. Lighter skin in Europe and lighter skin in parts of East Asia did not emerge through identical genetic changes. Evolution found similar solutions using different genetic tools. This means there was no single moment when humans became white, nor a single moment when humans became black. These are modern terms for a much older, slower process. The first times, Homo sapiens times, were almost certainly dark-skinned compared to many people alive today, because our species evolved in Africa under strong ultraviolet radiation. But even that must be stated carefully. They were not black in the modern social sense. They were ancient humans, with skin adapted to strong sunlight. The social categories came much, much later. The biology came first. Imagine the sun as a problem with two inherent dangers. If its radiation penetrates too deeply into your skin, it can damage folate and DNA. If it does not penetrate enough, you cannot produce sufficient vitamin D. Melanin acts as the dial. Turn it up where UV is brutal. Turn it down where UV is weak. Not because one skin color is inherently better, but because different environments demand different things from the body. That is why no single human skin color is the original, perfect version. Every shade is a record of survival. Dark skin is not primitive, light skin is not advanced, and brown skin is not an unfinished state. They are all testaments to enduring life. However, the modern world has disrupted these ancient rules. Today, people can traverse the planet in a matter of hours. A person whose ancestors adapted to weak northern sunlight might now live under the harsh equatorial sun. Conversely, someone whose ancestors adapted to strong tropical UV might reside in a cloudy northern city. Your skin still carries the story of ancient sunlight, yet your life may unfold under a completely different sky. Our bodies were shaped by specific places, but our lives are no longer confined to those places. And perhaps that is the most profound part of this story. Skin color feels permanent. It feels like identity, family, history, something you are born with and carry everywhere. But it is also powerful evidence of movement. Your skin is not just the color of your body. It is the shadow of ancient migrations. It is the trace of deserts crossed, coastlines followed, winters survived, and sunlight absorbed by people whose names are long forgotten. People who never knew they were shaping the face of humanity. They were simply trying to live long enough to have children, and over thousands of generations, the sun etched itself into their skin. So, why did humans become different colors? Because we left one place and strived to survive in many. Because the same star that gave us life also threatened to harm us. Because evolution had to solve two opposing problems simultaneously. Protect the body from sunlight and allow sunlight to enter. That is all skin color is. It is not a ranking, not a border, not proof that humans are separate. It is proof that humans are one species, flexible enough to survive almost anywhere. A species that began under the African sun, spread across the planet, and carried the memory of those skies on its skin. Every shade is a survival story. Every color is a map. And every human alive today walks around with a little piece of ancient sunlight written on their body. Your body carries a much older story than you might imagine, and that story did not end in the past. If you found this explanation compelling, please consider subscribing to Ancestral Dawn for more insights into what it means to be human. There is so much more buried within our shared human experience.